5.91. So it says tin fluoride is added to some toothpaste to aid in the prevention of tooth decay. What mass of fluoride in grams does 7.1 grams of the compound contain? So the question is, how many grams of fluoride are there in 7.10 grams of the tin fluoride? Or how many grams of fluoride are in 7.10 grams of this tin fluoride compound? So if I set my question up like that, it's helpful because now I know what units I want. I want grams of fluoride, not just grams of anything, grams of just the fluoride if I had 7.10 grams of the whole compound. So I'm going to need some relationships here. What relationships do I need and where will I get them? You want to have any ideas? So I might want molar mass. We know how to calculate that now. So if I look up the mass of tin, so I have one tin in my formula, so I'll do one of those. That's 118.71. And then I would add the mass of fluorine multiplied by 2, or I would add 2 masses of fluorine. And when I add that together, that relationship, that number adds up to 156.706 grams of tin fluoride equals 1 mole of tin fluoride. So if you're not sure what relationships you need and you can't map it out in your head, you can start just putting down some relationships. We know what molar mass is. We know how to calculate it. We know it relates the grams of something to 1 mole of that something. Maybe just start with that relationship, and it might help you think about what other relationships you need. Because we do have information given in terms of grams of this substance, so it makes sense that we would want to develop some relationships that involve that unit. So if we converted that 7.10 grams of tin fluoride into moles of tin fluoride using the molar mass relationship we just have, what other relationships could we use? Yes? Yeah, that's another way of going about this. So you might also say, well, I know that in a previous chapter we did mass percent. We figured out how to calculate that. So if you remember mass percent, we looked at it in terms of AMU, but you can also look at it in terms of grams. Right? So the mass percent is the mass of a part. In this case, we're interested in the fluorine, so it would be the fluorine, or the fluoride, over the total mass, which would be the whole compound. So if you wanted to get the mass percent, to get it as a percent, you'd multiply by 100. But we don't actually need a percent here. We just need the relationship. So when we did these before, we used AMUs, right? We got the numbers from the periodic table, we plugged them in AMUs, we multiplied by 100, and we got the mass percent. But we know now the masses on the periodic table are not just AMUs, they're also grams per mole. So we could get a gram relationship, basically that's the same as the mass percent, if we wanted to use that. So if we want the gram relationship as a fraction, we probably don't want to multiply by 100, but we would want to plug in grams here. So the mass of 1 fluorine, but actually we have 2 fluorines in the molecule. So the mass percent is the total mass of one substance divided by the total of all of the elements present. So if we multiplied that by 2, that would be 37.996. So that'd be grams of fluorine in the total mass, which we just added up, was 156.706. So that's a relationship. Right? The mass percent is a relationship. Technically, those grams don't cancel because they're not grams of the same substance. So that we can use them to convert grams of fluorine into grams of something else. So this is actually a really helpful relationship. So I'm going to just get rid of this since we've got that relationship now. That relationship will allow me to do the whole conversion. So if I want to use that, I can do that here. And I can go 37 point, wait, I want the grams of the compound to cancel, so I put the grams of compound on the bottom. 156.706 grams of tin fluoride should be equal to 37.996 grams of the fluorine. So that will give me the answer. And if I recognize that that one relationship will do the whole entire conversion, and I can figure out that relationship in the same way that we did mass percent earlier, I can use that. And if I do I will come up with 1.72 grams of fluorine. So if I start with 7.1 grams of the tin fluoride, 1.72 grams of that is just the fluoride. If I didn't recognize that relationship and I wanted to work from this relationship, what other method could I use? What other relationship might I have come up with instead of this direct relationship between the units I wanted? Well, technically there is, so that's a good question. So F2, if you just write F2, that implies that you have two fluorines bonded together. When I write SnF2, that's interpreted differently chemically, because when the nonmetal fluorine is bonded to another nonmetal fluorine, they're going to be sharing electrons, so both can have the same as a noble gas. When the nonmetal fluorine is bonded to a metal, there isn't going to be any sharing. So in this case, you'd have the tin with a +2 charge, and both fluorines would have their electrons all to themselves. They wouldn't be sharing at all, and they would both have a negative charge. So technically, there is no F2 in SnF2, because SnF2 has two fluorides that have negative charges. So they're just asking really about the grams of F- that are present. Good question. So if I wanted to use an alternative method and work from this relationship that I have, so if I started with my 7.10 grams of SnF2, I want to use this relationship. I know there's 156.706 grams of SnF2 equal to 1 mole of SnF2. What other relationship could I use to get from information about one substance to information about another substance? Oftentimes, and we'll see this especially when we get later in the semester, oftentimes we don't have a direct gram relationship between one substance and another substance. Between fluoride and tin fluoride, sometimes it's hard to get a gram-to-gram relationship if I want to do that conversion. But there will almost always be a mole-to-mole relationship provided to you in the question. So if you're dealing with one substance, which has its own identity, in this case the tin fluoride, SnF2, and the question asks you about information about a different substance, which in this case is the F minus, the fluoride, or it could be any example where you have information about one substance, you're asked to calculate information about a different substance. Usually the best thing to do is to convert to moles, because once you have moles of a substance, there's usually a balanced reaction, which we'll talk about later, or a formula for a substance that tells you the mole relationship, right? Because a mole is just a number of things. And the formula, for example, tells you the number of things. This formula here, right here, it tells me that for every one Sn atom, there are 2 F atoms. Right? The formula tells me the number of things, and that's what a mole is. It's a number of things. So when you have a formula, the subscripts in the formula tell you a relationship in moles. Right? That it doesn't tell me I've got 2 grams of fluorine for every 1 gram of tin. It tells me I've got 2 atoms of fluorine for every 1 atom of tin, or 2 moles of fluorine for every 1 mole of tin, because a mole is just a number of things. So I can use that as a relationship. I can recognize for every 1 mole of tin, that's equal to 2 moles of fluoride. And that comes from the formula for this particular compound. In this compound, I've got twice as many atoms of tin, or moles of tin, or fluoride, I should say, to every 1 mole of tin. So that's a relationship. And we're going to be doing more examples, and you'll see later in the semester how most of the time when you want to convert from one substance to a different substance, you need that mole relationship. And actually I can include the fluoride in there. So for every 1 mole of the compound, if I break it up, there's 2 moles of tin in it. Or, geez, there's 2 moles of fluoride in it, sorry. So I can use that as a relationship to convert to moles of that substance. And then once I have moles of a substance, if I want grams of the same substance, then I use the molar mass of that substance. So if I want to cancel moles of F and get grams of F, that just comes from the periodic table, 18.998. So now I got all this canceling. I've got the unit I want, and the answer is going to come out the same as my alternative approach up above.